For those of you who are sitting next to the projector, do your best. Not actually, do not swing your legs in any way that it moves the projector. Do not throw your backpack at my projector. Do not put your desk close to my projector because I'm recording and I need not to be doing this over and over again. Right? Not looking at anybody in particular. Just saying. All right. So this is a composite figure because obviously it has very different figures inside. If you look at the whole thing, you would not know what it is, right? You would not be able to name it. It's an irregular figure. But once you break it into pieces, you're like, oh, there is a rectangle, and something that looks like it, like a square. I have to count the squares to see that. A semicircle and a triangle, right? Well, this is my garden. This is the shape of my garden. And I'm trying to cover this entire garden with fake grass because we live in Texas, and y'all know that some houses out there in Oak Cliff, you drive by them and it looks like a desert because there has no grass. It just doesn't grow for some reason. So I'm just imagine that's mine, and for 1 square foot of fake grass, it will cost me $3 to buy it. That means I have to figure out how many square feet I have, right? Total. No, I just drew it.
No, I meant the square feet.
I just drew that. Okay, so the first thing that I'm going to do is grab one of the easy ones, right? Let's grab the one at the corner. What is the measurement of that?
5 by 3.
Let me move back a little bit. The idea of doing this, of separating it, is not just for the fun of it. The idea of doing that is so that we have a formula that actually works with that shape. Because if we look at the whole thing without dividing it, there is no formula you can use to find the area of it, is there? No, it's not possible because it's all kinds of crazy. But if we divide it into shapes that we recognize and we have formulas for, then I can use those formulas. So I want you to write this down. I know this is a rectangle, right? So what is the formula for the area of a rectangle? Base times height, right? That's it. And I'm going to put that right there to remind me that I'm going to need the base and the height of that particular figure to find the area of it. And then this one, it seems like it's a square because it has a measurement of 8 by 8 right in the middle. So for this one, what is the formula? Side times side, or length times length, right? Same thing. Or L squared, or S squared. What about the triangle at the bottom? What is the formula for that one? Base times height divided by 2. Good job. And why is it that we divide by 2 again? It's basically half of a square when you turn it into a square, right? What about the semicircle? What is the area? Or what is the area for that? What do I do? We don't start with the radius. Pi times r times r. But it is not a full square, so what do we do? At the end, we divide everything by 2, right? At the end, only at the end. First, you find the area of the entire circle, and then you divide it by 2 because we only have half of it. We have a semicircle. So now that we have the formulas that we need, now we can just plug in the numbers. What is the base of this figure? The base. 5 feet, right? By what? 3 feet. So what is the area? 15 feet. 15 feet squared. 5 times 3 is 15, and we're talking about squares, right? You can actually count the squares, and then you will count 15. On this one, it's the same way. We have 8 feet right here, and 8 feet right here, total. When you multiply, what do you get? 64 square feet, right? For the triangle, we have 4 feet as the base, right? What is the height? 2. So 4 times 2 divided by 2, what do we get? So 8 over 2 equals 4 square feet, right? And then for the last one, this will require a little more work. We know pi is 3.14. What is the radius then? How can I find the radius?
Divide by 2.
What are you looking at?
The diameter.
Diameter. That's what I wanted to hear. You're looking at the diameter. I know exactly what you meant, but I needed to point it out. You're looking at the diameter, right? Because it is the distance between one another circle to the other end, right? When you're looking at it from the front. And you know the radius is only half of that. So if the diameter is 8, then the radius must be 4, right? You can also count up, and they're still going to give you 4. So now we can multiply 4 times 4, right? And we get 3.14 times 16. What do we get?
I thought,
I'll do it on this side.
5,000.
Whoa. You shouldn't get thousands here. Careful. What did you do? Check your errors. Maybe the decimal went wrong. You what?
Oh, yeah. I forgot.
Yep. 50.24. Now that is the area of the entire circle, right? Do we have an entire circle? So what do you get when you divide by 2? 25.12 square feet, right? Okay. So now that I have all my areas, I can combine them, right? And let's add them over here. 25.12, is it? Plus 64.00, I don't have any decimals, plus 15.00, plus 4.00. Add all of these guys right here, you get 12 right here. That'll be 18. Carry 1, that'll be 9, 10. So I get 108.12 square feet total, right? Am I done with my calculations? Why not? By what? What? Why am I multiplying by 3? Yes, that's exactly right. We were doing the areas to find the total square footage, right? How many square feet do I have in my garden? Now that I know how many square feet I have, I can go and buy what I need, right? And every square foot of that fake lawn is going to cost me $3. So if I have 108.12 square feet, how much would it be total? What do you do? Just multiply by 3, right? Sounds like common sense. 6, 3, that'll be 4, 2, 3. It seems like I will have to pay $324.36 for my lawn. Now tell me, if I were, let's say that I didn't want to have anything over here. I did not want to cover this part but with lawn. What would I do to find the area of that, whatever is left? By what? By what? Why did we do it by 2 when we had a semicircle?
Because it was half.
It was half. Now what do we have? Do we have half of a circle? We have a fourth, right? So what should we divide by? 4, right? Because we have a complete circle, and we divide it by 4, it will give us the value of 1/4, right? You need to understand that. You will be tested on semicircles, meaning that you divide by 2, because you only have half, and you will be tested on quarter circles, or a fourth of a circle, because you only have a quarter of it. You don't have the entire thing. However, for any of them, you still have to find the area of the entire thing. Do not forget that. But I'm glad that you guys knew what to do. Well, majority of you. All right, let's move back. Go to your book. Where'd he go? Go to page 306, and I want you to work on number 4 individually. 306, and I want you to think of how we solved the other problem and apply the same information to this one. Separate it, identify what you need, what formulas you need, and then work on it. Let's go. Don't ask me any more questions. This should be very easy. So the first thing you do, you look at the picture, right? This is a rectangle, so it's base times height. The base is 5, the height is 4, right? So when you multiply it, what do you get? 20, and you were talking about feet, square feet. Yes.
I noticed that. Could you have combined it the half?
Yes, the semicircles. So if you combine the semicircle, you will get a whole circle, right? So you get the area of that, and that's it. You don't have to divide or multiply anything. You just find the area of the circle. So what do I need from that circle? The radius. What is it?
2.
It's 2 because diameter is 4, so the radius is 2. So it'll be 2 pi times 2 times 2. So 4 times pi, right? 12 what? 56 will be square feet for that one. And now I add the 20, and I get 32.56 square feet. And now that's not what I'm looking for. What am I looking for? Yes. How much would be for the square footage of the class, right? I'm trying to replace the entire thing. So you multiply that by 28. And you get 48, carry 4, 44, carry 4. 16, 20, carry 2, 24, 26. And then you get 12, carry 1, 11, carry 1, 5, 6, 8, 6, 1, 11, carry 1, 6, 7, 8, 9, 8, 9. And we have 2 numbers after the decimal. So we will be spending $911 and 68 cents on replacing that thing, right? I want you to always read the entire question because a lot of you would have just given me 32.56. And I told you many times that you're going to find that as an option, right? Every time the bad option is there. And you're like, oh, I got the right answer. You didn't. All right, let's go back over here and then work on this one. So if we had this triangle right here, this shape is an irregular shape. We don't have a name for it. What do we do? Divide it up into pieces that what? That we recognize, exactly. You divide it into shapes that we do know. So there is a triangle, there is a rectangle, and at the bottom I have a parallelogram. Now the first thing that we need to do is do what? Find the area, the formula areas, right? You have to find the formulas first. What is this? What is this one? And this one is exactly the same. A parallelogram has the same formula as a rectangle. So now that I know that, let's take a couple of minutes to do it on your own. You got it? What? You can, but it's the same thing as you do the whole thing. I'll show you in a minute. That's called the additive, the subtracting and additive rule. So basically what she was saying that I can take this one off and put it over here, and you can actually have a whole rectangle. You don't have to separate it anymore. But that's where the formula based on how it works. Because of that subtractive, you take that away and you add it to the other side, and it turns it into a rectangle. That's why it works. But just use that. Was it too much? You got it? What you got? Okay, we did something wrong there. So I'm glad that I did it this way when I cut it off right there. Let me explain it again. So the reason why the formula works for that one, so that one is easy, right? It's 4 times 2 is 8 divided by 2, 4. So this is 4 centimeters squared. And the other one is just 5 times 3, which is what? 15. And this one, you're wondering, why is it that I can just do base times height? Notice that if I take this away and place it over here, I end up with the rectangle, right? And, and that rectangle is 5 by 3, which is 15. That's where the parallelograms work with the base times height formulas. That's the only reason, because you can take it away and reshape it. You can. But I just want you to think that way. I just want you to use the bottom one as the base, and then find somewhere in the middle to where it goes all the way up. So it could be this one, or this one, or this one, as long as it's the total height. Because you don't measure yourself sideways, do you? No. You do it straight up, right from the bottom all the way to the top. You don't go like this and be like, yeah, but that's crazy. How are you going to be like, I'm 6'7"? That's all right. Parallelogram. Every time you have a parallelogram, you don't have to reshape anything. I was just showing you why the formula works. When you have a parallelogram, all you have to do is get the measurement of the bottom and find one of the measurements that goes all the way from the bottom to the top. And that's your base and your height. And that's all you need. Multiply those two and you're good to go. All right. So the area of the entire thing is 34 centimeters squared. The next one. So this one says that Sal has a tilting, tiling his his entryway. The floor plan is drawn on a grid unit. Each unit length represents 1 foot. The tile costs $2.25 per square foot. How much will Sal have to pay for his entryway? So when you divide this into pieces, you end up with what? That's not a square. And what else? A trapezoid. Why is that a trapezoid? It has at least 2 pair of parallel sides, right? A pair of parallel sides. That's it. That's really need at least one, right? And the formula for that one, I told you to change it to base 1 plus base 2 times the height divided by 2. It sounds like a lot, but it's really not a lot. Base 1 always uses the bottom one. So it'll be this one. What is it? 4, right? Plus base 2. Base 2 is the one on top. What is it? 7. And the height, I told you to go to the middle or somewhere that goes from the bottom all the way to the top. What is it? Yeah. 5, right? Times 5 divided by 2. So what is 4 plus 7? 11 times 5? 55 divided by 2? 27.5. So the area of that trapezoid is 27.5. What about the parallelogram? That's easy. It's just 4 by 4. 4 by 4? 16. Then you add 16 to that, and you get 5, 3, 43.50. That's the total area. Then you multiply that by 225. That's a lot of work. But I want you to do that at the end. Go ahead. That's your last part. Do it on your paper. 43.5 times 22.5. Wait, 2.25. I'm sorry. 2.25. For those of you watching the video because you did not take this home or whatever reason, this is your homework. It is page 309. All of this and all of this.
Wait,
Whoever did not have the page on their book, because there was a lot of people who didn't have it, so they had to watch the video. That's the homework. And for those of you, you have it on your paper, so in your book, just take it out. This page. Yes. I understand that we have not covered the top part, but I know you covered it in sixth grade. So try to remember what you did there, and then I'll know where you need help and what we need to do about it. Huh? Sixth grade. You're going to last year.